Okay, we have three graphs here, 3 lines on the right-hand side. We're going to try to figure out which graph is which according to these equations over here. When you're looking at an equation, you want it to be in slope-intercept form. That means y by itself. If you look at all three of these equations, they're all in slope-intercept form, meaning y is by itself. Now, none of them really look like slope-intercept form. The reason why they don't really look like slope-intercept form is slope-intercept form looks like this. It has an mx and then a b value. None of these appear to have b values. If you look at the first one, it's just y equals x. The next one is y equals 2x. Next one's y equals negative 3x. So it looks like none of them have b values. It's because they have a b value, but we don't write it. So what would the b value be if it's not there? Yeah. Yeah. These are all plus 0. Which means they all have the same y-intercept. They all have the same y-intercept of 0. And if you look at these graphs, that actually holds true. They all have the same y-intercept of 0, right in the middle. But they're all crossing that point. So the only thing that's different about these three graphs is their m values. Their m values meaning their slopes. Awesome. Here's how I would do it. If I was trying to match up these graphs to these equations, I would look at the graphs and try to calculate all their slopes. So looking over here, I'll start with graph A, meaning the red graph for me. I'm going to try to calculate the slope of graph A. To calculate that slope, you need to find 2 perfect points, meaning 2 spots where it crosses right in the grid. This is one spot right here that crosses in the grid. This is another spot right here that crosses in the grid. I could then figure out the slope by counting up 1, 2, and over 1. That means graph A has a slope of 2 over 1. Looking back at your equations, which one of those has a slope of 2 over 1? Does y equal x have a slope of 2? Does y equal 2x have a slope of 2? Or does y equal negative 3x have a slope of 2? Yeah, y equals 2x. That has a slope of 2. Right? The m value, the value in front of x, is 2. The next thing I would do is I would look at graph, I'm going to do C, so the blue one, and I'm going to see if I can calculate the slope of it. To calculate the slope of a graph, you find 2 perfect points. There's a lot of perfect points on graph C. So I'm just going to pick this one right here and this one right here. Yeah, and you can use any 2 points and it'll still work. You're going to go from left to right, so you're going to go over 1, up 1. This is my rise because I went up. This is my run because I went over. That means my slope is 1 over 1. Perfect. That would be represented by y equals x. So if you're looking over here, it would be graph C is the first one. Now, they didn't put a value in front of x, right? They just left it blank. That's because there's an invisible 1 there.
I thought x was
Negative 1 over 1. Like in the equation or in the picture?
in the equation. Like I thought just like for x alone, I thought it was a negative.
Oh, I thought it was a negative 1. There was a question we did yesterday where there was a negative symbol in front of the x. So if they did this, that would be negative 1 over 1. If there's nothing there, then we just assume it's a positive 1 over 1. Yeah. Also, by process of elimination, we can kind of figure out the third one, right? It's obviously going to be B. However, I'm going to go look at it anyway, just for good habits. So if I'm looking at the green one, I find 2 points. There's a point and there's a point. I go down 1, 2, 3, so that's negative 3. And to the right 1, it means my slope is negative 3 over 1, which is represented by the third graph. Awesome. Now, hypothetical situation. We could do this question without ever having to calculate a slope. So we're going to look back. I'm going to show you a trick on how you could do this question really fast without ever having to calculate any of these slopes. So for instance, if we pretended, I'm just going to get rid of all these plus zeros. If we pretended there was no grid there, they just give you 3 lines. The way that I could figure out which line is which is by understanding what slope represents. Slope represents the steepness of something. The bigger the number, the steeper it should be. So looking at these graphs, I have 3 different slopes. This one is a slope of 1. This one is a slope of 2. And this one is a slope of negative 3. If your slope is positive, it goes up from left to right. If it's negative, it goes down from left to right. There's only one negative slope here. It's the third one. So looking at this picture, the only line that's going down from left to right has to be that third one, because that's the only one with a negative slope. So just by looking at the pictures, I can be like, hey, this is the only one that's going down, so it must have a negative slope. The other 2 I could figure out by just saying which one's steeper. Steeper meaning like it goes up faster than the other one. So if you look at these lines, the steeper line is line A. That means the slope on line A has to be a bigger slope than the other one. So looking at the graph, 2 is a bigger slope than 1. So this one has to be the steeper graph, which is graph A. You can process of elimination really fast on questions like that, just by understanding what the slope is representing. It's how fast something's going up or down. Does that make sense to anybody? Like that's a quick way through it. Cool. Good stuff. Let's try another one. Okay, we have 3 questions here. We want to match these graphs to the lines. The only way we can do that is if our graphs are in slope-intercept form. That means y is by itself. If you look at the first equation, y is by itself. Y equals 3x plus 3. But if you look at the second equation, y is not by itself. So we need to practice getting that thing by itself. I'm going to give myself a little bit of space. I'm going to rewrite it up here. So I have x plus y equals 3. The way we get things by itself is by using opposite operations. So we need to move the x first. How do we move that x? We minus x. Right? Since that x is being added, we subtract it to the other side. On the left-hand side, it cancels. And all I'm left with is a y on the left side of the equal sign. On the right side of the equal sign, I have 3 minus x. Those cannot combine because they're different letters, right? One's a constant, has no letter, and the other one's an x. We also learned that we can reorder things. So instead of having it in this form, we could reorder it to be y equals negative x plus 3. Right, we reorder it. You guys seemed like you were getting a lot more confident in doing that yesterday. People were starting to get that algebra process. It's not easy. It takes a lot of practice. All right, we're going to try the third one. So if we look at the third one, if I want to rearrange that thing, I'm going to do it in kind of the margin on the side here. I have 6x minus 2y equals 6. My goal is to get y by itself. So I need to move things away from it. The first thing I need to move is the 6x. And I need to move additions and subtractions first. How can I move that 6x? Yeah, Drake. Minus 6x. Perfect. And what you do to one side, you do to the other side. So I also subtract 6x from 6. On the left-hand side, 6x minus 6x, they cancel each other out. Yep. And this is a tricky one because it looks like we should be plusing 6x, right? Is that what you're thinking the opposite is? So you got to pretend there's like an imaginary plus right here because that's a positive 6x. And then this negative right here is attached to the 2. It's like a negative 2. We actually just had this discussion yesterday in 20-1, right? Because the same stuff keeps coming up. And people even like 2 years later still view that as like, why aren't I adding that? So just imagine there's an invisible plus sign there. And then I know I need to subtract. When I subtract the 6x, they will cancel out. The negative is attached to the 2, so it's negative 2y equals 6 minus 6x. So remember, our process is you show your work, and then you reorganize your work. Then you show a work, and then you reorganize your work. Yes, sir?
When you minus the 6x from the front, you do it from the back. When you cancel out the 6.
Yeah, so if you look right, you're talking about right here, right? Like, why don't those 6s cancel out? Yeah. The reason they don't cancel out is they're not what we call like terms. So you can only subtract things that have the same letter in them. And if there is no letter, then we call it a constant value. And constants can only subtract from other constants. I like to pretend they're things. Right? So if I've got like this 6 just represents 6 apples, and this x represents 6 oranges. So if I had 6 apples and I subtracted away 6 oranges, it doesn't make a difference, right? I just have those two things. Yeah, you got it. All right, I got to get rid of that negative 2. Yes, sir. You divide. So this is a negative 2 times y. The opposite of timesing is dividing. So I'm going to divide everything by negative 2. I represent division like that, like a little bar. What I do to one number with division, I do to all numbers. So that I now have y all by itself on the left equals 6 divided by negative 2 is negative 3. Negative 6x divided by negative 2, negative and a negative becomes a positive 3x. Yes, sir. Yep. So look at that for a second. Just be like, oh, where did those numbers come from? A lot happened in that calculation. Right? We divided the numbers, but then there's also the negatives, so the symbols are switching. The last thing I would do is I'd rearrange it. Right? I like my mx to come first, so I'd rearrange this to be y equals 3x minus 3. Right? They just swap spots. And now you have that. And we're going to try to match up these graphs with these equations. And I'm going to try to do it without having to actually calculate anything. I'm just going to use a little bit of problem solving. Yes, sir. Okay. Okay. First thing I'm going to do, I'm going to look at graphs A, B, and C, and I'm going to look at what's different about them. If I look at graph A, it's going down from left to right. If I look at graph B and C, they're both going up from left to right. That means that graph A has a negative slope, while graph B and C have positive slopes. So I don't actually need to make any calculations. I can just look at them and know, okay, A is negative because it's going down. The other two are positive because they're going up. Which one of my equations has a negative slope? The right one? The right one's slope is that number right there, which is positive 3. This one, yeah, has that negative one. It's because we reversed it, right? And sometimes that's why it throws us off. Remember, we reversed these guys. So when we reverse those numbers, the symbol goes with it. So that's a positive 3x now. The negative slope is the second graph. So this one must be graph A. Now, looking at the first equation and the third equation, I have to match them up with equations B and C. Looking at equations B and C, equation B has a negative y-intercept. Equation C over here has a positive y-intercept. So that means I can look at my two remaining equations and say which one has a negative y-intercept, which one has a positive y-intercept. This one is a positive 3. This one is a negative 3. Well, this one up here is positive. So I can match up the graphs based on their y-intercepts. The first one has a positive y-intercept, it must be graph C. The third one has a negative y-intercept, it must be graph B. Worst case scenario, if you can't do those tricks or that thinking process, you could just calculate them, right? You could look at those and calculate the slope and match it up. It's just a little longer. The better you get at that, the quicker you'll be able to go through some questions, including next year. So next year, you're going to have to continue doing this stuff like matching graphs to the lines. And if you get good at these skills, it can take you about 2 seconds once you're like halfway through grade 10 usually. All righty. Is this easy compared to yesterday? No, still hard? Okay. I was like, I couldn't tell. Can't tell if you guys are just like tired or bored or both. We're going to look at a word problem. So this is Sari. Yeah, we're going to go with Sari. That looks like Sari. Sari, Monica, and Bruce participate in a 5-kilometer walk for charity. Each has a different plan to raise money for their sponsor. The graphs show how the amount of money raised related to the distance walked. So when you have a graph, we're just going to look at this one, for instance, Sari's graph. They are going to label their axes. They put an M here. That M must stand for money. They put a D here. That must stand for distance they've walked. We're going to talk about Sari's graph, and then we're going to actually try to answer some questions here. So if I'm looking at Sari's graph, there's 2 things that I can figure out. The first thing I can figure out is how much money she raises before she even starts the race. So before she starts the race, her distance is going to be at 0. She hasn't walked at all. That would be this point right here on the graph. If her distance is 0, how much money does she make? 0, right? She has 0 money. That means she starts with no money. The second thing I can figure out is the rate at which she makes money for her charity. That's known as your slope. So if I looked at this and I calculate, say, her slope, I notice that it goes up 8 and over 2. So her slope is 8 divided by 2, which is just 4. What that represents is she makes $4 for every kilometer. I assume it's kilometers. So she started at 0, right? We found her starting point, but then we found her rate, her slope at which she's increasing money. We can do the same thing for Monica. So if I'm looking at Monica and I say, okay, what does Monica start with for money? How much money does she start the race with? Yeah, I think we can estimate that's $3. I think that's fair to say. So she starts with 3. Yeah, so like maybe someone was like, I'll give you $3 just to run the race. And then even if she doesn't show up to the race, somehow she gets that $3. It's a sweet deal. Then if you want to figure out how much more she's making, you calculate her slope. That's the rate at which she's going to make money. So if we look at this, she doesn't get another nice point for a very long time. We're going to have to assume that this half point right there is 5. We're going to assume that's perfectly in between 4 and 6. That means she goes up 2 from 3 to 5 over 1. So 2 over 1 equals 2. That's the rate at which she makes money now. So she's getting $2 for every kilometer. If you're looking at the third one, Bruce, I want you to see if you can figure out what Bruce's starting value is for this charity and figure out the rate at which Bruce is making money for this charity. So I'll give you a second to try to find the starting value and the rate at which Bruce makes money. So if I look at these, Bruce's starting value, so that's a distance of 0, hasn't run at all, is at 5. I almost said 1. It's at 5, right? It's right here. We're going to assume it's perfectly between 4 and 6. We're going to call it 5. The slope is up 1, because it goes up just a little bit, and then over 1 means they're making $1 for every 1 kilometer they run. Awesome. Those 3 things that we just calculated, we calculated their slope and their starting value for all 3 graphs, are often called their y-intercept and their slope. Instead of rate of money making and how much they started at, you can just think about it as in terms of actual math, y-intercept and slope. So if you look at the first graph is m equals 2d plus 3. That means you're looking for somebody whose charity is going at a rate of $2 per kilometer and starts at $3. The person that has that is Monica in the middle. Hello, Miss Fink.
I filled up the bus.
Was it empty? Yeah, so like let's look at like Bruce's, for instance, because that one's like probably the hardest one to do on the y-axis. So when you get graphs like Bruce's, where it doesn't go up by 1, right? That makes it hard. Not very nice. So if you look at Bruce's, when you see what it's going up by, so for instance, it goes from 4, gentlemen, thank you. It goes from 4 to 8. I'm going to use red, maybe it'll stick out better. 4 to 8 like that, that means it's jumping by 4, which I think you're cool with. You're like, yeah, I see that's by 4. And then trying to figure out what the little individual blocks are. So this, which I'll do in blue, is halfway. So if you just divide 4 by 2, that'll tell you what's halfway. So halfway must be up by 2, which would be 6. And then if you did halfway in between 4 and 6, that would be like right in here. That must be going up by half of 2, which would be going up by 1s. So that makes this little invisible spot 5. It's messy, right? And you do have to always be careful with scales. On the x-axis, the same kind of thing's happening. I go from 0 to 2. That means halfway should be half of 0 to 2, which would be 1. And so on and so forth. Yeah. Oh, yeah. I didn't match any up yet. Sorry. Match up these equations. So let's look at this one right here. M equals 4 plus D. This is my slope. That means that's the rate at which you're doing something, making money in this case. The y-intercept is plus 0. That means you had a starting value of 0. So which equation had a rate of 4 but started at $0? Started. And then by process of elimination, Bruce must be this last one over here. But the reason Bruce is that last one is because it has a rate of 1 going up at $1 and started at $5. We are going to do more and more word problems because that's the applicability of all this. And as you get better and better, word problems get harder and harder as the years go on and more complex. But the whole idea of creating lines and equations is that you could actually apply them into real life situations. So that one day you could look at a line like this and say, how far do I have to run to make $100? Right? And you could use the equation or the graph to figure it out. There is applicability to everything we're doing in this unit, which is kind of nice. Okay. We got 4 guys right here. They're all in y equals form except for the third one. So I want you to try to rearrange that one on your own so that it's in slope-intercept form, y by itself. You have all this room. You're probably not going to need it. So if you want, you can rewrite it right there and start manipulating things. I'll give you a minute and then I'll do it. Then I'm going to let you work on your own. So if you're looking at this guy and you wanted to rearrange it, the first thing you need to move is the x. So I'm going to subtract x from both sides. It's going to cross out on the left. And then I'm going to show my work. So I still have negative 2y equals negative 8 minus x. Now, yeah, you may. Looking at this next step is the hardest step. So we have to get rid of that negative 2. The operation to get rid of the negative 2 would be division. Right? We're cool with dividing that because that's negative 2 times y. And when you divide it, you have to divide it by every number. That's the trick here. Because when we divide by negative 2 there, it cancels, which is nice. We divide by negative 2 there, but we also have to divide by negative 2 there. So remember, there's an invisible 1 that needs to be divided by 2. That's the thing people would probably miss. Okay, so make sure you're dividing every single number in the equation. Yes, sir. Yep. That should leave you with y equals negative 8 divided by negative 2 is positive 4. Negative 1 divided by negative 2 becomes plus 1 over 2x, like that. If you put 0.5x, you're not wrong, right? It's just we prefer to leave our things as fractions because fractions tell us rise and run. Decimals don't tell us much. So it's much better to have the fraction. Again, we should probably rearrange. So it's 1 over 2x plus 4. How many people got that? Did somebody get it? A couple? Oh, that's good. 2 people. That's a hard one. That's why I let you try it on your own. Right? So you can experience that, oh, what do I do with that value? Because it happens a couple of times in that question. And now hopefully you'll remember. You now have 4 equations, my bad. I want you to see if you can match up the graphs. Okay, so give it a shot. See if you can figure out which graph goes with which. They are labeled. The labeling is a little sticky. We're going to assume the labels are in a bad spot here. We're going to say that, yeah, I agree. Blue is D right here, so this is D. We're going to assume that G is the red one right here. We're going to assume that E is the green one. And we're going to assume that, oh, no, we're not. We're going to say E is orange. And we're going to assume that F is green. So D is blue, G is red, E is orange, F is green. Unless it literally told us that already and we screwed it up. That's okay. What's up? It tells you. Yeah, I just read it. I was like, that's not good. I screwed it up. But that's okay. That's just what we're going to go with. So go ahead and see if you can match those up. I'll show you how I would do it. And then you can do it 1,000 different ways, right? But I'll show you how I would attack this. So if I looked at these questions, I would notice that 2 of the equations have positive slopes and 2 of them have negative slopes. I could tell that by looking at the equations or by looking at the graphs. Looking at the graphs, these 2 have to be negative because they're going down left to right. These 2 have to be positive because they're going up left to right. Looking at the equations, I can figure out that these 2 both have negative slopes, so they must both be going down. So I can immediately know that these 2 must be these 2. Now, I don't know which one's which, but I can kind of match them now, right? I've narrowed it down. The difference between those 2 downward graphs that I just did in red is their y-intercepts. This one has a positive y-intercept of 5. This one has a negative y-intercept of something off the scale, but I know it's going to be negative. Looking back at my equations, this one has a positive y-intercept. This one has a negative y-intercept. So I know that the first one is the green line, which I called F. Because that had a negative slope with a positive y-intercept. If I look at the second negative slope question, that's the blue line, which I called D. I did name them wrong. Okay, that's why I'm saying the colors of them. And I knew that just by looking at their slopes and their y-intercepts. That's all I needed. Another way that you could do these things, we're going to look at the one we just created. Okay, so if I look at this beautiful one that I got by itself, the y equals positive 1 over 2 and then positive 4. That means I'm looking for a graph that has a slope of 1 over 2 and a y-intercept of 4. If you were to look, both of these last lines, they actually have the same slope. They both have a slope of 1 over 2. I know they have the same slope because they have the same steepness. We call that being parallel. Right? They're parallel lines because they're the same steepness. So the only thing different about them is their y-intercepts. I want one that has a y-intercept of 4. That's a y-intercept of 4. That means this is the orange line. I called the orange line line E. By process of elimination, I know that this one is the red one, which I called line G. If you weren't sure, I know it's that one because the y-intercept is -0.5. That's the same thing as saying -0.5. Looking at your graph, that's -0.5 for the y-intercept. You could have done that whole question without ever actually looking at the slopes, just by looking at y-intercepts and matching up y-intercepts. All right, last 4 here. So if you look at all 4 of these graphs, all 4 of these graphs have something the same, and all 4 of these graphs have something different. What's the same on all 4 of those? They're all positive slopes, meaning they're all going upwards. In fact, they all have the same slope. I know they have the same slope because they all have the same steepness. Notice that they're all going up at the exact same rate. This makes them something called parallel lines. They're never going to cross each other because they have the exact same steepness all the way up. That's what they have the same. What do they have different? Their y-intercepts. Every one of their y-intercepts is different. Line A has a y-intercept of 4. Line B has a y-intercept of 1. Line C has a y-intercept of -2. Line D has a y-intercept of -6. They all have different y-intercepts. So when we answer these questions, how are these 4 lines alike? They all have the same slope. I'm just going to put in quotation marks. That means they're parallel. I think I'm missing an R there. Parallel. Parallel. Yeah, I'm going to put another R in there. See if it looks right. Oh, that doesn't look right. No, 1 R. Parallel. Yep, 1 R. Don't know till you try it. How are these 4 lines different? They all have different y-intercepts. I like to write shorthand a lot, so I'm just going diff y-intercepts. Y-int. Cool. Our job. We're going to try to match these graphs to these 4 equations. The way I'm going to do that is by finding all their y-intercepts. So if I look at the first one, it says y equals 2x minus 2. That means I'm looking for a y-intercept of -2. Graph C has a y-intercept of -2. Y-intercept's right here. That's graph C. Yeah, for sure. You look at the equation beside it, right here. This one has a y-intercept of +4. Looking at my graphs, the y-intercept of +4 is graph A. Y-intercept +4, that's graph A. The last 2, I need to isolate things, right? So I need to isolate y, get it by itself, so I can figure out the y-intercept. I'm going to do it quick for you. So if I'm looking at this, I'm going to subtract 2x from both sides. That gives me -y equals 6 minus 2x. And I'm going to divide by -1. Right? That's an invisible -1 in front of that y. That gives me y equals -6 plus 2x. If you want, you could rearrange that so that it looked like this format, y equals 2x minus 6. either way, you should be hopefully recognizing -6 is the y-intercept. It's the constant value, the one that's not next to the x. The equation with a y-intercept of -6 is the orange one, which is graph D. It means my last one must be graph B. That's matching lines to equations or equations to lines, depending on how you want to look at it.